Okay, any questions on what we did on the rice cooking examples? Okay, the next thing that we're going to do is talk about airport operations. These are the two examples that we will be talking about in different circumstances. I will always refer to these examples. Of course, when you consider the airport operations, it is much more complex than the rice cooking example, because the airport is actually a huge structure where you have a number of things going on at the same time. So it's not going to be as easy as the rice cooking example to understand what's going on. So if you permit me, what I will do is I will write a few things that comes out of the clips that we have seen. First of all, so let me start with that. So this is basically, I am introducing some details. So airport operations. Number one, it's obviously very complex because there are many aspects of it. We have seen a view from the approaching plane. We have seen a view from the air traffic control tower. And we have seen a view from the gates. Now, another thing that is basically that strikes immediately is, if you remember the Hong Kong airport example, where people were walking towards the gate. I mean, they walked and walked and walked. It's very far away, actually. And in some airports, actually, it takes 20, 25 minutes to walk from one place to another. In some of them, it's even longer because you have to take another vehicle to transfer you from one part of the airport to the other. So one thing, obviously, which is very important for customers, if we are looking for customers, is proximity to gates. How close can somebody be to a certain gate? Now, you can build a huge airport where people might walk for 2 hours to go to their own gate. But that's not very reasonable because you need to catch some planes and so on. So this is one thing that immediately strikes everything except complexity. Now, the second thing, of course, which is very important, is the carriers, the airline companies itself. Now, they seem to be taking a lot of risks. They seem to be actually the key element of everything we see around. Now, why do you think they are the key? Now, let's consider very simple airport operation. You have a number of shops there. Let's say that you have 2 gates, okay? And we have a number of things that we do around the gates. Remember from your own experience as well. I mean, there are a number of things that you have security control, ticket control, whatever, everything is done in the gate, okay? Moreover, there are a number of services that comes to the plane, okay? Cleaning service, fuel service, maintenance service, and so on. Once the plane is close to the gate, it's at the gate. So there are a number of things going on downstairs that we don't usually see. A number of things are going on in the plane, okay, cleaning up the plane and so on before we enter, actually, and after we leave, okay? And then we have everything that goes on during the flight. Now, let's leave the complexities during the flight aside. Let's leave the complexities of controlling a number of airlines, planes together as traffic controller, which are extremely important problems, of course. But let's leave that. Let's emphasize a simple problem where we have 2 gates, a number of shops around, and then services that are given to these 2 gates and the carriers. Okay, is that clear? I'm sort of like made the problem smaller. Now, when do you think the gate is going to be used? A certain gate. So we have 2 gates. When are they going to be used? I mean, what determines the time that they are going to be used?
15 minutes before the
Okay.
going.
Okay, so you have two actions for each plane. Comes to the gate, brings up some passengers, stays at the gate, takes new passengers, and there are a number of other things that is going on at the same time, and leaves the gate. So you would only expect customers coming to the gate around these time periods. So they are not going to go to the gates continuously. They are only going to go to the gates when there is a flight coming in and when there is a flight going out. Okay? And other times are not going to be used. For example, let me give an example from Ankara Esenboğa Airport. In Ankara Esenboğa Airport, most of the gates are used at 3 time intervals in a given day. There are only 3 time intervals that the airport is used. I think once in the morning, in between 8 and 11, where you have a number of flights coming in, a number of flights coming out, same planes, of course. And then you have one burst in the afternoon. I think this is a smaller burst, if I'm not mistaken. And then you have one burst in the evening. So we have 17 to, I think, at 9 o'clock at night. Okay? Well, more or less. I don't know this for sure, actually. I'm just guessing. But there are 3 very, very heavy traffic coming in and leaving out. The same thing is true for Munich Airport, for example. There are 3 intervals in which the airport is extremely busy. Now, how does this affect everything? Think about the shops. Okay? The shops are going to see passengers in between these hours, actually. Not before that, not after that. I mean, usually you have a very small number of people who are going to go to the airport 5 hours before the flight. Okay, you don't go there. And once you are at a certain airport, if you don't have your next flight, okay, you are not going to stay at the airport, am I right? You want to leave the airport as quick as possible. Sometimes if you are very tired, you can sit down, drink a cup of coffee, but that is only going to take 15 minutes. So this means that the busy period at the airport operations are always centered around the arrival times and departure times of the carriers. So that's the reason why I said key arrival and departure times. So it means that if I am going to plan my little newspaper shop there, okay, how am I going to plan my little newspaper shop? I would look at the flights. When are they arriving? When are they leaving? And plan my operations accordingly. Because that's the time when I'm going to see my customers. If I am the beer shop, okay, I have to make sure that I catch the customers who are going to wait for more than an hour. Because if the time in between is more than an hour, then passengers may want to relax. Otherwise, they usually walk very fast and wait for the next departure. But if you have 2 hours, you go somewhere and sit down. Let's say that I am planning the size of the gate. The size of the gate is a function of the carrier's plane size that can approach to that gate. If we're talking about a plane that can have 300 passengers and versus 100 passengers, then the space that you are going to allocate will be different. So you can see that the driving factor is the schedule. Okay, this is a word that you may want to keep in mind. Çok yaşa. This is a schedule of the carriers determines the way that work flows in the airport operations. Of course, there are some airports which are always busy. But what's the meaning of always busy? For example, let's take Istanbul Airport. I think 2 times a day, Istanbul Airport is utilizing almost all the gates in 2 time intervals. All the gates are full. But if you go out of those 2 time intervals, 60%, 50%, 40%, 30% of the gates are fully utilized. So if your shop is around that 30% gate, your work schedule is going to be different than if your shop is somewhere else. So it depends on the gates that are assigned. There are a number of, it's very complex, you can see. A number of independent stakeholders are expecting a lot of things from the airport operations. It's very complex. But this is just to show that everything is geared towards arrivals and departure schedules. Now, what else? Well, it turns out that this is another word that you may want to learn, layout. So we have two words that you have to learn the meaning. One of them is schedule. The other one is layout. Okay, what is the layout? Let's say that this is the airport. This is the entrance from the city. This is basically, these are the gates. And then you have shops here. And then you walk to the gates or whatever. Now, the composition of this is called layout. Layout in the sense that the walking paths, the places where shops are, and so on are decided in that layout. You can call it an architectural plan. But layout is always important functionally as well, because if you are going to have a lot of transfers, you have to make sure that passengers transferring from one side of the airport to the next side of the airport should be able to make the next flight if the walking distance is a reasonable time. In Heathrow Airport, for example, I remember waiting for 2 hours for the bus to pick us up from one part of the airport to the next because there was no walking path. So we had to miss the flight. Okay, now these are very important things that should be planned, and layout of the area, gate, the whole airport, the terminal building, and so on turns out to be very important in understanding these relations. Okay, now this is the extent that I want to give with respect to the operations in general. Of course, you have different observations personally or from the clips, but I think these are the important factors that affect the decisions in an airport. Now, let's go and now start discussing the operations, the process of the things that we do after a plane arrives at a gate. So let me start with that. So this is actually what I asked yesterday, and this is what we are going to discuss. So we have a plane arriving at a gate. Now, there is a formal definition of a gate. Anybody who is not sure about what a gate is? Okay, we all know what a gate is. Am I right? Gate is basically what I mean by a gate is this is the location where people embark and disembark. Embark meaning that they go to the plane, and disembark means that they come out of the plane. And then there is a certain hall with some seats. And if you are waiting for the plane to depart, you sit down and wait. If you are leaving, you are usually not going to sit there. You are not expected to sit. You simply go out and pick up your luggage or go to the next plane. Now, let's say that a plane arrived at a gate. What are the things that is done, do you think, when this plane arrives? Okay, so let's try to understand the details of that process. This is what I will be doing now. Okay, any ideas on? Yeah?
After the passengers left, cleaning up.
Okay, well, you have said a number of them together. So, first of all, when plane arrives, it takes some time for the plane to stop. Am I right? It's not immediate. So you have a certain duration. The gate, the automatic door will come and fix itself to the plane, and then you have to make sure that it is secured and so on. So this is number one. Yes?
Plane needs to stop at specific location for the bridge.
Okay, yeah. And then the bridge comes and plane stops. So we have this bridge problem and so on. Next thing is, actually, as you said, passengers are out. Now, do we have anything before passengers are out? In other words, do we have a specific group of passengers going out first? Or, for example, what happens to people with some walking difficulties? Do they go out first or regular passengers go out first? Which one?
Regular.
Okay, regular goes out first. Okay. Then passengers go out. Then other passengers go out. These are regular, and let's say other passengers go out. Now, do we immediately accept new passengers in? No. We have a number of operations. The first one is cleaning operation. It might not be in that order. Yes?
Luggages will be taken from the plane.
Okay. But that can be done in parallel to some others, of course. But baggage, in general, baggage is going to be carried out. Yes? Yes?
Refuel the plane.
Okay, refuel the plane, but before refueling, we have other things. That's one of the things, actually. You're right, refuel. Anything else? Yes?
Cabin crew may change.
Okay, now cabin crew is going to go out first. And they have to make sure that certain things are satisfied, certain regulations, before they go out. And then the new cabin crew is going to come. New cabin crew. I have no specific order. I'm just listing them. But there is definitely a relation between each of them. If the other crew doesn't leave, the new crew would not enter. Okay, what else? I'm looking for new hands. Okay, go ahead.
You can check electronical and mechanical parts of the plane for the next flight.
Okay, let's call it maintenance.
Fresh meals loaded for
Okay, so new supplies, food supplies come in. Okay, what else? Is that plane going to stay there forever? Is the plane going to stay at the gate forever? No, we already have the new cabin crew coming in. So when are we going to have the new passengers in? Okay, new passengers are going to go in. So again, we might have specific passengers going in first, and then other new passengers in. Okay.
Before new passengers, maybe cabin gate will change.
Okay, so you're going to move the plane to another gate?
Maybe it can be possible.
Okay, they will. Okay, that's a possibility, but we usually are not going to observe it if we are waiting for that plane to leave as a customer. So that might be true, but that's something that we don't want to do. Why? What is the most expensive part of this whole airport operation? Fuel? Okay, anything else that comes to your mind? Do you know the cost of each plane? Do you know how much a plane costs? Well, $100 million probably, like one reasonable sized plane. It might be even more. Okay? So you can see that the aim of all operations is to make sure that that plane flies all the time, if it is possible. Okay? Because every time that it flies, it is going to get some revenue. So I can now come to some kind of a performance measure. Let's say that I'm a carrier. I am approaching to a gate. What should be my objective? My objective should be to stay there as little as possible and leave to the next flight. Okay? So that I will be carrying customers and making more money. And every time that I arrive at a certain location, I want to go and maximize the total number of miles that I make per day, per month, or whatever under given rules, of course. So actually, when we started to observe this process, but we didn't have any aim in observing this process. So this is not a typical thing that we do as IEs, actually. We usually have to have an aim in mind in order to observe a certain process. Otherwise, it doesn't make sense because we can observe it in several different ways. You can look it from the tower, you can look it from the bottom, you can look it from the top, but that doesn't mean anything. Now, of course, this is, I skipped this on purpose. So my aim is actually when I have a plane arriving at the gate, I want to finish everything that I should do as quick as possible and make sure that the plane leaves as fast as possible. So I prepare my schedules accordingly. I leave a certain time interval, but I make sure that I obey those schedules. Okay? So, performance measures. Time spent at the gate. This is for planes, of course. And I want to make sure that it is as little as possible. Now all these other things that I do started to have a meaning. Am I right? Because now when I'm going to evaluate them, I will evaluate them in terms of the total time that is spent at the gate. So new passengers are in, and then we fly out. Let's say there might be some other things. But now you can see that, well, we didn't load the baggage of the new customers. Okay? So we need to load. We didn't forget about the food, but we left the baggage out. So we have to make sure that we have to load the baggage of new customers. And you may ask, where is my newspaper? You might have newspaper being loaded as well. Okay? So you can see that there are a number of things. Now, each of these are actually a certain process, if you come to think of it. For example, plane stops. If you analyze that in detail, first of all, there is a certain way that the plane is going to approach to the gate. The gate should be empty. Okay? It takes time. Remember yesterday? And then you have some people waving hands and so on. Okay? Making sure that the plane approaches in a correct way. There are all lines drawn in the surface of the airport, actually. So, for example, if you are a 777, there is a certain line which is drawn for 777s. Another line for Airbus 340s. So they know actually where to go, but still those people with their hands, they help the pilot to make sure that it comes there. So you can see that there are a number of little things that are done at each step. But this is the detail level that we wanted to take in this section. In the other section, they may give me more details, or they may approach me in a cruder way. Okay? But this is actually the way that we are going to analyze all these processes. All these processes, cleaning process, it's not a one-shot process. It depends on how many cleaning people you have to clean the plane. It depends on how dirty it was from the previous flight. If the previous flight was a very long flight, it's obvious that it is going to take more time. If the previous flight is a shorter flight, it's obvious that the plane will be cleaner. Okay? So you can see that there are a large number of factors to consider. But each of them has a certain way of doing it. For example, how are we going to take the baggage out? Well, we used to do it manually. I remember 40 years ago, people would go there and keep up luggage and put it down. Okay? But nowadays, actually, it is all automatic. Maybe we can use a better conveyor to do it faster. Am I right? There is a certain current technology which is used to do that. If we use another technology, it might be much better. Of course, then it means that we have to spend some money. But the idea here is that each of them deserves some attention. Do you think that that attention is economically viable? Is it important to spend that energy to each of those processes? What do you think the answer is? What do you think the answer is? Is it economically viable to spend a lot of energy on how are we going to take the baggage out of the plane? It's no, is one answer. Why?
Because we should spend our money more important things to minimize the time.
Okay, of course. But what happens if the time that it takes for the baggage to go out and time that it takes for the baggage to be loaded again is 2 hours, and you want to spend in the gate at most 1.5 hours?
What I want to say is that if my system take the baggage out in 15 minutes and load the new ones in 15 minutes,
So,
I don't think it's very important to lower it to 10 minutes.
okay. So very good actually. This is the correct logic. So what I will do is I would look at each process separately first. I would analyze. Then I should have a certain way of selecting the more important ones and give more energy to those more important ones. Now in this case, the more important ones is the ones that are longer. But also there is another relation. Now, there is a certain crew who handles baggage out and baggage in. Now, for example, on the other hand, there is a certain crew who handles the things that go on in the plane. Passengers in, passengers out. Now, the total time for passengers in and passenger out might be short, but there might be a number of different processes which are related to that. So you can only, for example, have certain things once passengers are in. Okay? So what you have to do is you have to make sure that that complex relation is satisfied. In other words, what you might have is you might have something like this. So let me draw it over here. You might have a very complex structure. Okay, so now what we have here is that's a casual list of things that we should do. There is no relation between each other. But think about the courses that you are going to take at this university. All of them, most of them are 3 units, am I right? So they are of equal value. You don't know which one is going to be more valuable. But when you look at the prerequisite structure, you know what prerequisites are. The courses that you should complete before you can take another one. You should pass, actually. So what happens is that there is a certain network that represents the relation between different activities that you are going to do. So let's say that with each node, I describe a certain part of the action. Plane stops, for example. Now, this is, let's say, 1, this is 2, this is 3, 4, 5, and 6. Let's say that I have 6 activities. Now, I know that I can start activity 2 once activity 1 is finished. So there is a certain relation between these 2 activities. You can only take mathematics to 25 if you pass calculus 1. On the other hand, you can take humanities only if you pass the English courses. Whereas you can take IE-102 without any restriction. Okay? You can take a number of courses in your curriculum without any restriction. So it means that there are some requirements for you to do this. This might be pushing this one, and you might have a relation like this, and then this might be the requirements that you have to complete all your jobs. For example, what does this mean? This means that you need to finish 3 before you can start 6. So you can see that the relation is actually more complex. So you will never know whether this baggage in, baggage out process is important or not unless you make an analysis of this kind. Now, we're going to see applications of this in 2 weeks' time. We're going to look at some networks, and we're going to analyze mathematically how we can deal with these type of problems. What is our objective here? Our objective is to complete all the activities in the shortest possible time. Am I right? Okay, so this is what we're going to do actually. So this is what we're going to analyze mathematically. So you're going to learn details of this in some other courses in the second and third year actually. So this is one way of representing the problem that we have in this abstract manner. Now, what is the benefit of this representation? Now, once I know, given a certain network, once I know how to minimize the total time required to complete all the operations, if I know the technique to do that, then what does it mean? Whether you have this process, this set of processes, or another set of processes that comes from rice cooking, or another set of processes that comes from automobile manufacturing, or another set of processes that comes from bank operations, doesn't matter. If I can represent it in this way, and if I know how to handle it, I will be handle all those set of problems. So in this department, what you're going to learn is, you're going to learn how to solve these type of problems once they are represented in a network form with different objectives and different problem structures. Okay, we're going to see two examples, for example, in this course, in a very simple way. But nobody is going to tell you on how you are going to transform this to this form. Okay, so in this course, we're going to do some examples, exercises, in order for you to be able to do that. This is sort of the art part of the engineering. Engineering also has an art part. Every engineering field has an art part, and that art part is what we call the way we see, look at things, and the way we transform those things into mathematical terms. So this is the art part of industrial engineering. We analyze processes, and then we convert them into some structures that we know how to deal with in general. So those courses where you're going to learn how to handle networks might be very abstract for you. Okay? We would require you to learn a high level of mathematics to handle those type of problems. But once you know how to deal with it, you can see that, and if you know how to convert a real problem structure to this, you will be able to handle those. The objective of this course is actually to give the bridge between these two. So we're going to spend a lot of time on these type of issues in a qualitative manner, but we're going to spend some time just to show you that we can handle these type of representations, and hopefully we're going to see how we can convert this information to this one in using simple examples. So this is the aim. Okay, any questions on this? Now, let's go a little bit one step further. So now I know how I can represent this. It looks very nice. And there is a certain relation between these processes. And my aim is to the total time that this plane spends at the gate. I want to minimize that. Now, I can give you some numbers. The airlines who were able to cut down this time that a plane spends at the gate with reasonable percentages turned out to be the companies who are making the most profit among all the others. So one of the initial ones is Southwest Airlines. So if you Google Southwest Airlines, okay, you're going to learn a lot of things about how they managed this time to become even smaller. For example, Southwest Airlines has a way of assigning seats. They assign seats unless you pay an enormous amount of money. They don't assign you any seat number, but if you are early in the gate, they give you number 1. and they take passengers according to those numbers into the plane. So if you are number 1, you can sit anywhere you want. But what happens is that they were able to show that that is much faster than looking for a specific number. So the time that it takes for all passengers to get into the plane becomes almost half of what it was before. Now, of course, you cannot do it in longer flights. Southwest Airlines only flies at most 2 hours or 3 hours. They don't have flights from one continent to the other. Okay? But if you have flights from one continent to the other, then you might observe that you are divided among some groups. So every time a certain group is invited to the plane, so that the people in the plane does not create a traffic problem when they are going to their seat. So for example, they first invite this group of people, then the other group of people, and so on in a certain order, so that they are not going to interfere with each other. Okay? So these are all techniques that you can use to increase the total time, to decrease the total time it takes for the passengers to go in. Okay? So these are the tools. So you can see that each of these processes actually requires some attention. But question is, how are we going to deal with that attention? It might be the case that if you look at, for example, this activity 4, it doesn't require any other activity that comes after it to have 4 completed. So it means that you can complete 4 simply before everything is completed. Now, if 4 is baggage out, for example, then you don't need to decrease the time from 15 minutes to 10 minutes because it's not going to change anything. On the other hand, you can see that if you change this time from 1 to 3, probably the total time is going to decrease. Now, we will be able to find techniques for which we should concentrate. Which process should we concentrate on so that we can decrease the total time? Okay, as IEs, we might be working on a single detailed process to make it better. Once it is decided that it is the process that should be improved, and if that's the case, then we will find different ways of improving it. So if it is necessary, we might use a different technology to take the baggage out, rather than doing it manually. Okay? Questions? Okay. Now, let's say that these are the activities. Now, take any of the activities and tell me, you have your own observations. Tell me how you can improve them to decrease the total time. Any ideas? Are you using the planes a lot? Maybe 10 times a year? Who is flying 10 times a year? Who is flying 5 times in between 5 and 10? 1 and 2 per year? Oh, maybe all of you. Okay, so tell me from your observations, what are the improvements that you can bring on this total time that you observe in Turkish Airlines or AnadoluJet? AnadoluJet is faster than Turkish Airlines, by the way, with respect to total time that it spends in the gate. Okay, any questions? Yes. Any suggestions? Yes.
The path is shorter because I remember that we walk so much place to reach the plane.
Okay. So what you are saying is that if the plane is closer, but how is it going to help with respect to this time? The time that the plane spends in a gate.
So we will go faster. So
You will go faster to the gate.
I will come to gate.
Okay.
And I will reach the plane.
Oh, the distance between the gate and the plane
Yes.
might be shorter.
Yes.
Okay, well, that's a possibility, but what is the distance that we're talking about? For example, I mean, what is the total distance that you walk from the gate to the plane? Tell me a number. 200 meters?
I don't know, but it came too long to me.
Okay, it depends where you are flying. Do you agree on this? Do you think that this is a major problem? Okay, why not? Then maybe if you are going down the stairs, for example, replacing it with escalators or another automated thing, you might make it faster. Or you can change the layout and the plane approaches to the gate in a nicer way. Okay, I always thought the following way. These are the planes parking, and we have the terminal building like this. Okay, why not have a terminal building with some mouths going out, and let these be the gates, so that distance is going to be smaller. Okay, that's a possibility. Okay, so how am I going to write that? Distance from gate to plane. Okay, because I'm going to write these myself. Okay, yes?
We are waiting too much to take our baggage back. Maybe it should be faster to baggage out from the plane and...
Okay, is it going to change the time that the plane spends at the gate? Okay, now this is important, I accept that. But for the problem that we posed, it has nothing to do with it. Am I right? Because it's not going to change the time that the plane stays at the gate. But of course, as a passenger, this is going to be a concern when we look at other part of the airport operations.
I just understand that only problems.
Okay, this is the problem that we are going to limit ourselves. Yes.
Maybe we can change the new passengers that they are settled to new plane.
Okay.
When we enter the plane, there is a big time. There is a lot of time spending. Maybe we can change it for example, the first passenger maybe can sit the back of the plane.
Okay.
And that will be.
So you are saying that passengers can be admitted according to some rules. Admission. Admission of passengers with a rule. That was what I was saying actually. They have groups, Group A, Group B, Group C. They first accept Group A, but Turkish Airlines never obeys those. So every time that you have a Turkish Airlines flight, everybody gets closer to the door, and then we kick each other and enter. Okay, yes?
I observed that the free shops and the gates, the distance between them is very long.
Okay.
If we build the shops near the gate,
Okay.
the distance will be lower.
Yeah.
And usually the shoppers are waiting the passengers who has already
Okay.
the plane. So this problem will be solved.
Okay, so which part of this process will it affect?
None of them, but...
Okay, yeah, it's the same thing. Okay, it's a problem, I accept, but not for this specific one. So now you can see that...
New passengers.
Okay, well, new passengers, are they always delaying the plane? We don't know that. If that's the case, putting the stores nearby may not necessarily change that, because they will be spending all their time in, and if they know that they are closer, they might even stay more. Okay?
But in the table they say final call for the Istanbul plane.
Okay.
People say, people look at the table and still they are on the queue. They don't care about the passengers who wait them. Usually they do it.
Okay, but putting the shops closer, is it going to change it?
Maybe.
Maybe, we don't know. Okay, but still it is not very much related to what we are trying to do here. Because we are now assuming that the passengers are there, we are going to get them into the plane. Okay, because that's what happens. Okay, yes?
Actually, I said that last year too, and making the plane smaller can decrease most of the things that...
Okay, if you make the plane smaller, of course you are going to require more space in the airport, then you need more gates. Okay, smaller planes. Now, this is actually, of course, something which is a remedy, maybe, but this is not very reasonable to think. Why? Because we are considering here a very short-term problem. Am I right? It's a short-term problem. I'm trying to reduce the time. You are suggesting me to invest millions and millions, create smaller planes.
I don't mean it's reasonable. It's the answer for the question. It's just a way to spend
Okay.
time.
Well, it doesn't necessarily is true because it's not linear. In other words, if the plane is smaller, the time is not going to be half of the previous time. Okay, it's going to be less than that because you have certain operations that you need to do regardless the number of passengers.
It also reduces baggage out in time and fueling time, passenger time,
It's not necessarily linear.
food supply time.
It's not necessarily linear. Okay, if for every passenger you spend half of the time, that might be true, but it's not the case. There are certain fixed operations that you have to do. Maintenance. Regardless the size of the plane, you spend maybe 20 minutes to check certain engine parts. Whether it's a small engine or a large engine is not going to change that. Okay, but that's an idea. Yes?
Maybe a crane can have passenger to sit, and the road in the plane can be wider.
Okay, the road, okay, that's very nice actually. So that they will have ample time in the seat so that people can move together. Okay, so rows, less number of rows. Less rows in the plane will make the passengers move in quickly. Okay, anything else? Yes? No, not you. You are okay.
When plane leaves the gate to the direction of backward, it takes too much time. I don't know if it is true usage because of planes don't have reverse gear.
Okay, yeah.
Maybe true architecture
They can go forward,
and
actually.
there shouldn't be to use the reverse direction.
So we might make some of the movements of the plane better so that it will leave much faster rather than slower. So let me write this here. So faster plane movements, which is going to decrease the total time. Okay, one more. Yes.
The buses that are peak as to the plane can be more faster.
Okay. This is actually, you're right. I only consider the case where you walk in through a gate to the plane. But if you have buses, actually, it is a more problematic case as well. I accept that. Now, one thing that I will mention, we can increase this. Actually, we will, if we had more time, we would have actually more options coming in. But let me, for example, mention about this one, which is very critical. This might bring an improvement. But what are we losing if we increase the space in between two rows? We are losing seats. Seats means that we are losing money. Of course, this is actually what we call a trade-off. This is important. Every decision that we make, every change that we bring in, actually brings a trade-off. It is going to increase something that we haven't observed before, and it is going to make a change for the better direction. So by having less rows in a plane, we're going to have passengers moving in faster, but we're going to have probably less revenue coming from that plane. So there is always a trade-off. If you do it this way, okay, you are going to make one thing better, the other part is going to be worse off. What should we look at then when we are making a decision of this sort? We should look at the total advantage, total cost savings that we are going to reach. We are going to lose money because we are not going to have two passengers. We're going to have two less passengers, but we're going to have 5 minutes faster entrance of the passengers. Is it worthwhile? This is actually what we do. We always evaluate, industrial engineers, create alternatives, evaluate trade-offs. If there is a situation where there is no trade-off, then there is no decision situation. Okay? We are only helpful if there are alternatives, decision situations, and trade-offs between different things, different decisions. Okay, so if I summarize, these are the things that we have seen today. Keywords. Performance measure. Extremely important because it specifies what we have done. Otherwise, we are unstructured people. Okay, we have to know the performance measure when we are talking about something. The idea of improvement, okay, is important, but it's not very straightforward. We have to make some analysis. Complex situations and mathematical representation. We're going to learn mathematical generic mathematical structures. Generic means that regardless of the problem environment, we will know how to deal with numbers, functions, and so on. And then it should be our role to convert the real situation to those functional forms. Okay, so this is what we're going to learn in the next 3.5 years. Questions? Okay, I'll see you next week on Wednesday.